In today's video, we'll be talking about resistance. After watching this video, you should be able to tell me what a resistor is, be able to tell me what affects the amount of resistance in a wire, and use and apply Ohm's law, which is going to be a very important formula and law that we're going to be using throughout the rest of this electricity unit. So make sure you get that down. So let's get right into it. Just a reminder, electrons are what is carrying this charge in a wire. Okay, they are what carry the energy either from the battery or from the power company. And basically these charge carriers will lose their energy in the circuit to what's called a load. And the load could be something like a light bulb, okay, so there's a load, or say your microwave or your hair dryer or whatever it is that's using energy from your circuit. Okay, and wherever that energy is being lost, that's called a voltage drop. Okay, basically energy is being lost and used or changed into another form, whether it be heat or to spin a fan or whatever the case may be. Okay, and so charge goes through these wires in a circuit, and today what we're talking about is these guys, the light bulb, the hair dryer, the fan, whatever the case it may be, and in terms of them using up the energy and the resistance that they apply to the circuit. So let's kind of just talk about what resistance is. Resistance is basically how hard it is for the electrons to flow, if you will, or the charge to flow through a circuit. Okay? And resistance is based upon how much current you get from applying an amount of voltage. Okay? So if you push hard on the electrons, which be basically increasing the voltage, remember voltage is just a potential difference. So if you push really hard on the electrons, more current should flow. Okay, you're going to get more movement through the circuit. But basically, the resistance provided by the circuit will actually slow that current. And this is measured in something called ohms. Okay, and it's spelled kind of funny. It's basically named after this guy named George Ohm, and the symbol is the omega, which to me looks more like a horseshoe, but that is the symbol, is omega. Okay, so resistance is measured in ohms, and the symbol is omega. And this is just something to, I guess, some science humor. If any of you guys are into like circuits and electronics, this is something called a resistor. I mean, these bands all have various values based upon their color, and it says join the resistance, and then you have all of them going ohm. Pretty funny. Anyway, let's keep going on, just because a lot of people don't find science humor that great. So there are some factors affecting the resistance in a wire. Basically, the first thing is the length of the wire. And this makes sense to me. The longer the wire, the more resistance you're going to have, because it takes, the path that the charge has to go is over a longer stretch. So when you're sending electricity, say, from a power plant in California to, say, Wisconsin, which doesn't happen, but let's say it did, the amount of resistance that electricity will feel from moving from a power plant in California to Wisconsin is a lot more than, say, the power plant in Oak Creek. Okay, so the length of the wire is going to determine how much resistance it has. The cross-sectional area of the wire. Okay, bigger wires provide less resistance just because there's more room for flowage to occur. Okay, so larger wires will have basically less resistance than, say, smaller wires. Okay, and there's a numerical value for the wires that you buy if you go to a store and you're looking to buy like speaker wires versus the wiring in your house. Well, the wiring in your house are going to be a lot thicker than, say, speaker wires, just because there's a lot more current flowing through the wiring in your house. And then finally, the material that the wire is made of. Clearly, plastic would not be a very good material to send electricity through, since plastic is not a conductor. It turns out silver is one of the best known materials for conducting electricity. The problem is silver turns out to be relatively pricey, and so to do a bunch of silver wiring in your house would be pretty expensive. I don't know, maybe some singers like P. Diddy or whatever have silver wiring in their house. I don't know. But most of our houses are probably made out of the next best choice, which is copper. Okay, and copper, although expensive, isn't nearly as expensive as, say, silver. The other day I bought some wiring for my house, and around 100 feet of wire was around $50. So, take it for what it's worth. I was surprised to see the cost of wiring. So here is Ohm's law. Okay? And Ohm's law, there's a couple ways you can write it, and here's two, okay, where you have R equals V divided by I, or V equals I times R, or really I could have another one where you have I by itself. I equals V over R. What do all these letters mean? Well, R is the resistance, okay, and remember resistance is measured in ohms, okay, which is that horseshoe-shaped thing. V stands for volts, and volts is measured in volts, or the symbol is V, and then I is the current, okay, the current running through the circuit, and that is represented with an A for amps, okay. So just these three things are what make up Ohm's law. So it's actually a relatively simple formula, but it's used all the time. So this is one worth memorizing, at least one form of them, of the formula, and then you can manipulate it to basically do whatever you need to find out. Okay, so you certainly could write all three of these down, but basically the one I personally remember is this one, V equals I times R, and then I can just manipulate it to get the rest. Okay. Here's a little graph of Ohm's law, where as you increase the current, and the voltage increases, basically it's saying resistance is going to increase because the slope is resistance. So if a material does obey Ohm's law, which in our class all materials we're going to say obey Ohm's law. We won't get into materials that really don't obey Ohm's law. The line will be straight. Okay. So let's do some practice problems. Okay, so remember current is I. Okay, how can we make current go down? Okay, well basically we could either A, decrease the voltage, we could B, decrease the resistance, C, we could increase the voltage, or D, we could increase the resistance. Okay, so how can we make current get bigger? Well, this is the formula of Ohm's law I remember. V equals I times R, and then if we want to deal with I, let's get I by itself. I equals V over R. Okay. If we decrease the voltage, would that increase current according to this formula? And if you just even throw pretend numbers in there, the answer would be no. All right. What if we decrease the resistance? What if we make this R get smaller on this fraction here? Would that increase the current? And the answer is yes. So B would be 1. What about increasing the voltage, giving more push to the charge in the wire? And that turns out to, yes, increase the current. Increasing the resistance, so making this number bigger on the bottom of the fraction, would not increase the current, and so that would not help you. Okay, so let's keep moving right along. Problem: if the resistance of a circuit were tripled, then the current to the circuit would be blank. Okay, so remember the formula of Ohm's law I use is V equals I times R, and we're worried about the current, so I'm going to get that by itself again. So I equals V over R, and basically it's saying if the voltage remains constant, that there is no change to it, and the resistance were tripled, so you make this number get bigger, so like times 3, what would happen to the current in the circuit? The current would have a 3-fold decrease. A 3-fold decrease. Okay, so this would get 3 times smaller. If you make the resistance 3 times bigger and the voltage does not change, the current would get 3 times smaller. Okay. All right, well let's do some number crunching using Ohm's law. It says a color TV has a current of 1.99 amps. Okay, and I'm just going to round that up to 2 just to make it simpler for the math. So current is I, all right, and I equals 2 amps. All right, when connected to a 120 volt household circuit. So my V is 120 volts. All right, what is the resistance in ohms of the TV set? Okay, so I again am going to be using Ohm's law because I'm wondering what the heck is the resistance, where V equals I times R. And I want to get R by itself. So what I really am going to deduce here is R equals V over I. And I'm going to put my numbers in, just do some number crunching. 120 volts divided by a current of 2 amps. 120 divided by 2, unless something has changed recently, we would have 60 ohms as our answer for the resistance in this TV. Okay, we'll do many more examples in class, but this just gives you a flavor for basically what Ohm's law is all about. I will see you guys in the next video.